Hi, my name's John Davis. I'm 51 and I live in Maidenhead in Berkshire. I've got two kids, aged 17 and 15, and I work for Vodafone. I've worked for Vodafone for around 7 years. When I was at school, I liked science and maths, and I liked real-world applications of those things. So I chose an engineering degree at Warwick. I didn't really know much about engineering before I started, to be honest, and I didn't know what I was going to be most interested in. So I was lucky to choose a course that was quite flexible. It was very broad to start with, and then there were lots of options. So you could work out what you liked as you went along and choose those options and steer the things which you wanted to study. During my degree, I did some very practical things, like designing and making car and bike components using computer-aided design and manufacturing. I also did some very theoretical things, like learning the maths and the equations that you need to model fluid flow and heat flow. This was the bit I was really interested in. We used it, for example, to work out how to model the flow of smoke around a burning building, or even how the shape of an F1 car would affect its maximum speed. The same maths and physics can even be used to predict the path that hurricanes take across the world. In this type of modelling, data and statistics are really important, and the computer programs that we wrote and ran often used to end up producing large sets of data, lots and lots of numbers. So we learned to analyse the data using a whole load of different techniques and tools. Here's an example of the kind of thing which I've been talking about. It's the intake rotor of a jet aircraft, and it's been modelled in a computer. What you can see is lots of little sections, and each section has its own data associated with it. And the model, in fact, works out the stress that each part of the component is under. The blue areas are showing areas that are not under very much stress, and the red areas are showing areas which are under a lot of stress. So if you actually built this component and made it and put it into a jet engine, then if it was going to break, it would be breaking in the red areas. This information, when analysed, allows the engineers to make sure that the designs that they create are as accurate as they can be and as efficient as possible. This is another example. This time the airflow around a Formula One car is being analysed. The red areas are where the air is moving fast, and the green and blue areas are where it's moving more slowly. This allows the engineers to work out the drag and also the downforce, which obviously help them to design the car in the best way. This is another, it's a mathematical model with lots of data. The red areas are showing where the sea surface temperature is much warmer than normal. And in fact, this phenomena some of you may have heard of is called El Nino. But the maths and the physics behind it is just the same. It's all data and maths and equations. This last slide is representing the smart grid, which is something which I'm very interested in. So you can see power producers like the wind turbines. You can see some transmission with the towers, and you can see people who are using the power and monitoring its transmission. All of these things are producing data, and that allows data scientists and engineers to analyse and optimise everything. So how about my current role? Well, currently I work in the part of Vodafone which deals with the Internet of Things, and my role is in cybersecurity. So what's the Internet of Things? It's all about connected items, so cars, gas and electricity meters, factory equipment, health monitors, smart watches, buildings, farms, you name it. They're now all becoming connected. You hear a lot about hacking and passwords and data being stolen. So how do we avoid this happening? How do we keep us safe? Well, all of this connect has massive amounts of data that are moving around, and that's how it becomes smart and becomes useful. But how do we keep track of it? How do we know what's going on? Well, we spend a long time looking at all that data and using tools to find out how it works and looking for problems and all sorts of things. So it's a bit like a teacher looking at a mark book with a red pen. We need to find where the problems are. Here are some of the tools that we may use to analyse data. The first one in the top left is all about filtering data. So data can often have noise, and there are ways that you can smooth out that noise. So you can see the red line is much more uppy and downy than the blue one. Anomalies, things that are different, are always of interest. Maybe everything is going fine and then suddenly there's one problem which you have to spot. Patterns, the bottom left shows you is clustering areas and other data is clustering in other areas. And correlations, things that are linked to other things and vary in the same way. Here are some more ideas of what to think about when you're thinking up your experiments and your data analysis. The top left is about the scientific method. It's the most basic thing that you can have. You have a question, you have some ideas, you do an experiment and get some results, and then you get some conclusions. A double-blind study is another thing which you may have come across, and it's a very fair way to do a test without any bias. Correlation or causation. This is one that people often get confused about, that things which vary in the same way, they don't always cause each other. Sometimes they're just correlated. Here are some resources that I think are interesting. They're loosely about data, although a little bit wider, about science and some other topics too. Mythbusters are really good fun. They're great scientists and always take an engineering approach to things. Brian Cox makes some good TV programs with about physics, but with a little bit of a comedy edge. Stephen Levitt and Tim Harford are economists, so they're always dealing with statistics, and they always manage to see past the noise that everybody else gets stuck in and see how things really are. The films by David Attenborough, A Life on Our Planet, The Imitation Game and The Social Dilemma, all tell us really interesting things about the world that we live in, and often with lots of data, lots of experiments and lots of statistics. I'd like to finish this brief talk by showing you how beautiful data can be and how amazing and powerful analysis and statistics can be. This is an animation of the globe. It's flattened out into an oval shape, but basically the top and the bottom are the two poles. And what you can see here is the line of mixing between the cold air and the warm air. This is where you get cold fronts and warm fronts. I've just started the animation, and you can see the evolution over time and the movement of these fronts and the way that they cut off into little whirls and whirlpools, just like water going down a stream. I think this is one of the most beautiful animations I've ever seen. Thank you very much for listening.